AI psychosis. It's a non-clinical term used to describe those who rely so heavily on chatbots.
Picture yourself looking ahead to the future of work and life. 2026 is much nearer than you may realize. The best way to understand how digital platforms, automation, data streams, and commonly used tools will change the way we do things is to look at what the new technology trends for 2026 will look like. These are not futuristic ideas. They represent real developments that are happening now in research labs, pilot programs, schools, factories, hospitals, and business settings. By 2026, a number of these new developments will have progressed from being newly adopted to being accepted as part of our daily processes and routines. Agentic AI and autonomous agents. As we approach 2026, the term AI assistant will become outdated as we move towards more agentic AI systems that utilize reasoning, planning, and initiating. Imagine an AI capable of generating a marketing strategy, conducting multiple testing scenarios in a single night, launching the most effective strategy, and reallocating funds based on real-time outcomes, all prior to your waking. Research Nesta estimates that by 2026, the autonomous AI marketplace will be valued at $11.79 billion and expand at an annual rate of over 40% until 2035. The term Agentic AI describes systems capable of performing several steps to achieve a goal without constant input from humans. Instead of being responsive to individual prompts, agents can deconstruct a specific goal into smaller tasks, prioritize the tasks, complete the tasks, review the results, and optimize the next steps to be undertaken. These agents can process these multitasking activities through their integrated memory, reasoning modules, and planning engine, and in this sense, act similarly to that of a human-valued employee in a business workplace. The agentic AI capabilities will allow businesses to support reporting, scheduling, onboarding, and customer communications processes without hiring more personnel. For an individual, agentic AI systems will be integrated into their productivity platforms, research tools, and email platforms. They will conduct daily tasks, track documents, and create presentation materials through the automated collection of related files. Human-AI collaboration tools. With the help of collaboration tools that bring together the best of human effort and artificial intelligence, businesses no longer need to worry about their ability to utilize their internal team members. With the use of these tools, team members now have an effective way of organizing their work by streamlining their processes, resulting in improved speed of completing tasks. By providing employees with data that helps them understand how to do their job better and clarify what risks exist, collaboration tools offer team members the ability to approve and agree upon their recommendations before they proceed. However, a company must always have its team members actively engaged in overseeing the projects as well as providing direction. Finally, employees can perform their jobs more accurately and with much less energy than in the past. For example, data analysts can identify behavioral trends of potential customers. Instructors can provide timely feedback to learners who need to improve their performance, and designers can evaluate design concepts without having to build each prototype. Because of the efficiencies achieved through collaboration, many organizations benefit from increased visibility, improved speed of work, and the ability to offer a higher level of quality through greater scrutiny. AI governance and regulation. As artificial intelligence continues to grow in complexity and scale, AI governance will move from an optional consideration to an essential requirement for technology and policy debate by 2026. In conjunction with the EU's AI Act, which will take effect in 2025, and in conjunction with additional new legislation in North America and the Asia-Pacific, organizations will now be required to provide documentation of transparency, equity, and bias-related screening of each AI model used by their organization. By 2030, the global market for AI governance will grow from $227.6 million in 2024 to $1.4 billion, with compliance becoming one of the fastest-growing segments of the AI marketplace. The framework for AI governance includes regulations, standards, and structural guidance to guide the design, deployment and management of AI and AI-related products and services. Regulators look at issues of safety, fairness, transparency, and accountability in developing governance frameworks. Sectors that deal with sensitive data, like healthcare, finance, and public services, have heightened scrutiny. Governance documentation, model testing, risk classification, audit trails, and user disclosure create a strong foundation for AI governance. Increasingly, clearer regulations mean that a predictable path exists for companies that will be utilizing AI to develop a product or service that meets both legal and ethical expectations. Instead of winging it, businesses can adopt clear, defined standards for transparency, data safety, and risk management practices to help protect users from abuse, promote user safety, and improve trust. For current leaders in AI creation and innovation, adoption of a governance process will spur growth in the accuracy and thoroughness of their documentation and testing. Consumers will have a greater level of safety and transparency. Neural interfaces, brain-computer interfaces. Neural interfaces are computer programs that take electrical signals from the brain and convert those signals into commands for computers by using electrodes to read the electrical signals from the brain and by using machine learning algorithms to interpret the signals and determine what action a person is trying to perform. There are both invasive devices that are implanted into the brain and non-invasive devices that are attached to the outside of the head. Currently, neural interfaces are being used primarily by research institutions for medical purposes, particularly to help people with paralysis control devices like computers or to communicate with other people. The potential benefits of neural interfaces for enhancing accessibility exist across many different areas of life. For example, they may allow people with paralysis to control their own prosthetic limbs, enter text using their thoughts, control their wheelchairs, or communicate more easily. In addition to helping people in a medical setting, the simplest non-invasive neural interface devices may eventually find their way into applications like gaming, training, or tracking a person's level of attention. In terms of opportunities for businesses, neural interface devices can enhance rehabilitation programs or training systems for specialized occupations. For the general public, lighter wearable versions of non-invasive devices may be incorporated into many types of consumer products for purposes of monitoring the user's health and for use as hands-free control devices. Generative AI 2.0. Generative AI 2.0 is an evolution of generative systems in their ability to better understand structured data, complex requests, contextual cues, and industry-specific guidelines. These models produce reasoning that is more accurate, concise, and based on a stronger foundation for every type of output: text, images, tables, charts, and code. The models have the capacity to combine multiple data streams, adhere to given constraints, and produce finished work with fewer errors than previous versions. According to McKinsey & Company, the economic potential of generative AI, this trend may create between $2.6 and $4.4 trillion of value annually across all industries. Low-code, no-code, and AI-assisted development. Low-code and no-code platforms are also expected to contribute significantly to business software development efforts by 2026, when business users will be able to build applications with interfaces without the need for heavy coding. What took months to do can be accomplished within hours using the drag-and-drop approach, and Gartner predicts that the low-code market will reach around $44.5 billion by 2026, where a large percentage of technology products, potentially around 80%, can be developed by people other than IT professionals. Such applications use visual development, and lately also AI support for UI development, pathway suggestion, error identification, and logic development for plain language input, thus reducing the complexity of developing web, mobile, or internal applications. Technical teams can come up with prototypes very quickly, and anyone, not necessarily a developer, can build solutions for internal business requirements, like HR-related form submissions, inventory management, and basic reporting, where developers can leverage the AI support tools for faster code, testing, and documentation processes. This aligns well with the current app development trends, which target less complex development cycles. Sustainable tech and green computing. Sustainable technologies are those that promote energy efficiency and lower carbon emissions through improved operational processes. Green computing uses low-power processors, software that is aware of greenhouse gases, renewably powered data centers, and thermal waste redirection through improved cooling. Companies track the carbon impacts of their computing tasks and develop tools to use fewer resources. The business opportunity stems from the ability of businesses to both reduce their operating expenses while still achieving their sustainability goals. As data center operations become more efficient, development teams can reduce costs associated with processing time by eliminating unnecessary compute cycles. For consumers, the lifetime of computers will typically be increased and less energy will be consumed. In addition, government regulators may provide incentives to encourage businesses to reduce their digital carbon emissions, transforming sustainability from an abstract goal into a measurable competitive advantage. Edge AI and TinyML. Edge AI is the use of machine learning algorithms in some form of device, such as a phone or computer. TinyML is an attempt to make smaller versions of these algorithms so they can work in very small amounts of energy and memory on microcontrollers. By doing this, we can allow all our processing to happen locally and therefore reduce our reliance on expensive and often unreliable online infrastructure, speeding everything that we do and giving us greater control of our data. Augmented reality AR. Augmented reality creates a digital layer on top of what an individual sees in the real world using a mobile device, smartphones, tablets, head-mounted displays, sensors and cameras, and computer vision to map the area around them, so it appears as though virtual objects are fixed in place relative to where you are looking. Unlike VR, which completely blocks off the real-world view and places a computer-generated environment in front of the user, AR enables users to see their surroundings, but also integrate additional useful digital information into that view. By 2026, the AR industry will shift from being an experimental technology to a practical, everyday device. AR devices will become thinner and faster and will gain increased technology capabilities, allowing users to integrate virtual digital content into their everyday lifestyles. According to Fortune Business Insights, the global AR market is estimated to reach $140.34 billion in 2025 and will increase to $1,716.37 billion by 2032, creating a 43% CAGR over the same timeframe, highlighting that AR is moving toward mainstream acceptance in the digital interactive world. As AR technology evolves, so will how the user interacts with digital content, as we will have the ability to virtually immerse ourselves in the world around us and no longer be limited by physical screens. Retailers can offer customers an augmented reality experience to view how their desired product would look in their home before they buy it. Science students will be able to interactively manipulate complex scientific 3D models. Field technicians will be able to pull up repair instructions on top of the equipment they are repairing. Employee training can be developed that guides employees through various procedures using visual references and overlays. The increased ability to train, develop, and enhance overall comprehension will reduce the number of mistakes employees make, allowing organizations to effectively develop their employees' skill sets. Data fabric and real-time analytics. The concept of a data fabric refers to an integrated structure that connects disparate data between multiple cloud environments, storage repositories, and software applications. The data fabric acts as a single unified layer where data can be easily discovered, accessed, and analyzed. Real-time analytics allows for the processing of continuous data streams rather than relying solely on batch reports, allowing organizations to be more reactive to events as they happen. Through the combination of these technologies, an organization can identify issues such as anomalous transactions, disruptions within the supply chain, or equipment modifications more quickly than before. The ability to analyze emerging patterns immediately with insight enables support teams to resolve issues before they escalate. Medical frameworks can track patient information in real time, while logistics companies can monitor tracking data on vehicles continuously. Having this capability will not only improve decision-making and reduce downtime, but will also help shape web development trends, such as the creation of more flexible and data-driven applications. Digital twins everywhere. The digital twin represents a real-time digital copy of a product or service. This representation of the physical item receives real-time data from the actual product or service, so it can adjust to any changes as they occur. Digital twins can be used to analyze the performance of the product or service, identify potential issues, and test changes prior to implementing them on the actual product or service. Several industries utilize digital twins to monitor machinery, facilities, transportation, and public infrastructure. Digital twins provide opportunity for growth. Both manufacturers can test new layouts within their plants without shutting down production. Energy companies can predict changes in energy consumption. Urban planners can see what's happening in their cities and plan for traffic congestion and changes in the environment before making decisions. Healthcare providers can see how many patients they have and where they are by looking at the digital twin of their hospital. By creating a digital version of their product or service to test new ideas and processes, companies can create more accurate plans, reduce waste, and execute projects more safely than if they were designing and building with a physical version. By testing ideas and processes in a digital twin format versus physically, companies can bring new products and services to market faster. Swarm robotics. Swarm robotics is the collective behavior of small-sized machines that engage with one another to work together using basic principles of cooperation. These machines work collaboratively because they share information about their environment and change their movements based on what they see other robots doing. Together, swarm robotic units can perform very complex tasks, although the capabilities of any individual unit are very limited. The swarm robotics concept is based on biological behaviors, such as those exhibited by ant colonies and groups of birds. Agricultural businesses may be able to use drone swarms to survey their crops. Warehouses could potentially use fleets of robots to transport inventory or send swarms of small robots to help locate survivors in a disaster zone. In contrast to using just one large machine, using a swarm will allow an organization to cover a larger area, be more resilient, and be less expensive. Additionally, the failure of one unit in a swarm does not bring down the entire operation, as all the remaining units will continue to work. Autonomous mobility and robot access. Robotaxis are a type of service that takes care of everything for their customers, including driving them where they need to go, waiting at red lights, etc. The challenge with this service model is that it doesn't exist yet here in the US because of safety regulations. Autonomous vehicles and robotaxis could help cities and states improve their traffic systems by helping to reduce congestion. Robot taxis can help you save time by removing obstacles that could slow down your travels, such as traffic jams, and they can help you save money by removing the need for you to pay to ride in an automobile. Robotaxis also allow businesses to automate their delivery processes by allowing them to use a machine instead of a person to handle deliveries. In addition, organizations that use autonomous shuttles will have greater flexibility in how they transport people and goods in a safe and efficient manner. Quantum computing applications. A quantum computer utilizes qubits, which have the potential to exist in multiple states at once, thus allowing the quantum computer to complete certain calculations much faster than an equivalent classical computer would. A quantum algorithm can explore many different alternatives at the same time, which means it provides considerable advantages in solving problems related to optimization, cryptography, and materials science. However, quantum computing technology will be limited because of two issues. First, quantum computers are extremely sensitive to errors. Second, quantum computing systems must be maintained under very specific environmental conditions in order to operate properly. Future research into molecules will allow researchers to create new drugs. Transportation companies will be able to increase operational efficiency by using exponentially larger amounts of potential routes. Research into new types of batteries and solar panels will produce applications for renewable energy systems. Financial services companies will be able to create sophisticated models to assess risk. By 2026, there will likely begin to be hybrid solutions that incorporate both the benefits of quantum and classical computational models available in select markets and industries. Spatial computing and XR. Spatial computing integrates digital content with the real world using 3D mapping, sensor arrays, and interactive tools. Extended reality covers augmented, virtual, and mixed realities. Spatial computing platforms continuously track a user's motion and location to integrate virtual content naturally into the physical environment. As a result, spatial computing provides immersive environments where users interact with digital data as if it exists in the same space as them. The opportunity architects can analyze and visualize full-scale building designs. Manufacturers can develop better trained employees using visualized processes, and teams can collaborate on joint projects across digital spaces. Students can learn through hands-on activities with digital media. As all of these tools provide greater depth of understanding and less opportunity for error in the design, training, and communication processes, they will ultimately lead to improved performance. Each trend reflects steady progress rather than speculation. Some technologies are already integrated into daily routines, while others remain in early stages but show clear direction. That will be the end of our video today, and with that, make sure to like, share, and subscribe to our channel, and turn on the notifications bell so as to be notified whenever we make a new upload. See you in our next video.